Hey everyone, Professor Baldwin here, and today we're going to learn about polynomial division. Sounds complex, might look a little complex, but if you remember just normal division, it'll help you out a lot. And I'm going to show you some tricks. Remember with normal division, you have the dividend, which is being divided by the divisor, and then you end up with a quotient and sometimes a remainder. For a polynomial, we can write each of those in function format. So the polynomial p of x is equal to lowercase d of x, which is your divisor, times q of x, your quotient, plus the remainder. Right? So if we had 8 divided by 3, that's equal to 2 with a remainder of 2. Or 8 equals our divisor, 3 times our quotient, 2, plus our remainder, 2. See, it's the same thing. Now, let's look at an example where we're going to divide this given polynomial by a given divisor, x plus 2. And let's see what that looks like. Now, the first tip that I have to give you is pay attention to each of your terms. When you're doing division, you have to have a placeholder for every term. So I like to rewrite my polynomials, making sure that I have a placeholder for everyone. So my first term is x to the 4th, but notice my second term is an x squared. So I have 0x cubes. Then I have my minus 2x squared. And notice I have 0 x's. And then I have my constant of 3. This gives me a placeholder for those two missing terms, right? But because the coefficients of them are 0, it doesn't change the meaning of that polynomial. So now let's write out the division. So we'd have x to the 4th plus 0x cubed minus 2x squared plus 0x plus 3. And we're dividing this by x plus 2. Now, when you go to divide, you're looking at your first terms. So we're looking at what do we need for x to be multiplied by to give us x to the 4th. And that would be x cubed. Because if we do x cubed times x plus 2, we get x to the 4th. So that's going to cancel out when we subtract, plus 2x cubed. So we're going to subtract x to the 4th and subtract 2x cubed. And that will give us, these guys cancel out, so negative 2x cubed, and then we bring down our next term, minus 2x squared. Now I'm looking at those first terms again. So negative 2x cubed, and I have an x. I need to multiply by a negative 2x squared. Because notice, if I do negative 2x squared times x plus 2, I get negative 2x cubed, because I'm trying to get this first term to be identical so that they'll cancel out, minus 4x squared. Remember, I'm subtracting these. So if I'm subtracting a negative 2x cubed, I'm adding a 2x cubed, and I'm subtracting a negative 4x squared, I'm going to add a 4x squared. The negative 2x cubed gets canceled out. Negative 2x squared plus 4x squared is a positive 2x squared. And I bring down that 0x. Okay, now I need to look at 2x squared and my x, and I need to multiply by a positive 2x. because 2x times x plus 2 will give me 2x squared plus 4x. So I'm going to subtract 2x squared, subtract 4x, the 2x squared cancels, and I have minus 4x plus 3, right? I bring the 3 down. And my last one. I'm going from x to negative 4x, so I'm going to multiply by negative 4. That'll give me a negative 4. Here, we'll do it here. Negative 4 times x plus 2 equals negative 4x minus 8. And I'm subtracting that, so it's an adding 4x and an adding 8. The 4x's will cancel, and I have a remainder of 11. This means I can rewrite my polynomial p of x is going to be equal to my divisor, x plus 2, times my quotient, x cubed minus 2x squared plus 2x minus 4, and then adding that remainder of 11. That was pretty ugly, right? Okay, if you look at this theorem, the remainder theorem, it tells us if a number c is substituted into a polynomial, f of x, then f of c is the remainder that would be obtained by dividing f of x by x minus c. Then there's a little more language in the textbook about how this remainder theorem brings us to what's called synthetic division. And what synthetic division allows us to do is really just do the division looking at the coefficients of each of our terms. But in order to do that, you need to make sure that your given polynomial has each term represented. So remember, we rewrote our polynomial above. We need to do it again. So this is x to the 4th plus 0x cubed minus 2x squared plus 0x plus 3. It is super duper important to have those placeholders where you don't have the variables, right? We didn't have an x cubed in our given polynomial, so we need to have that coefficient of 0 there. Same with the x. And then we're dividing this by x plus 2. But notice that synthetic division and the remainder theorem are talking about x minus c. So how do we rewrite this as x minus c? Well, x plus 2 is the same as x minus a negative 2. So we're going to divide by negative 2. This is where we're going to do a little magic. So negative 2 is our divisor. And synthetic division, we put it in this little box. And then next to it, we write the coefficient for each of our terms. So the coefficient of our first term is 1. So we put a 1. Coefficient of our second term is 0. Then we have a negative 2, a 0, and we have a 3. Now we do the synthetic division. I like to draw my line first, and I draw a vertical line in the area of that constant term. Here it's that 3. First step is to bring down your first coefficient, which is 1. Then you're going to multiply the divisor, negative 2, by that 1, and you get a negative 2. Now in this second column, we're going to actually add these together. 0 plus negative 2 is negative 2. Now I multiply this result, negative 2, by the divisor, negative 2, to get 4. Again, in the column, we add to get 2. And this number 2 gets multiplied by the divisor, negative 2, to give us negative 4. Add 0 and negative 4, and you get negative 4. Multiply the negative 4 by the divisor, negative 2, and you get 8. Add 8 and 3, you get 11, and you're done. Now, look at what this tells us. This tells us that we have a remainder of 11. And we have a constant term of -4. Our next term is a positive 2x. And the term before that is a negative 2x squared. And that first term is 1x cubed. Now I'm going to rewrite it up here again, just so that we can compare it. So we have x cubed minus 2x squared plus 2x minus 4, and that's plus 11. Remember, this is our quotient and our remainder. Now I'm going to scroll back to what we just did, which was the exact same division, and notice we had x cubed minus 2x squared plus 2x minus 4 plus 11. These two things are identical. Synthetic division gives you the exact same result as that long division we did earlier. So master synthetic division. It will save you so much time. And to help you master it, we're going to do a couple more examples. This example, we're asked to use synthetic division in order to find the function values. So remember from the remainder theorem that f of x gives us an answer of x minus c. So we can divide by this x value. So we're going to do -1 for the synthetic division. And then remember, we need to have a placeholder for every single possible term. Notice that we're missing that x squared. So I would rewrite this. It's 1x to the 4th minus 3x cubed plus 0x squared plus 2x plus 8. Rewriting it always saves me. So now I know my coefficients. 1, -3, 0, 2, and 8. If you miss that 0, you could end up with the wrong answer. Let's draw our division line, and we want that vertical bar where our constant term is. Okay, remember, step 1. Bring down that first coefficient. Step 2, multiply that by your divisor. We get -1. Now we add vertically. -3 plus -1 is -4. Multiply that result by the divisor -1 to get a positive 4. Add vertically, then you multiply. Then you add vertically. Then you multiply. And you add vertically. Now we got a result of 10. This is telling us that f of -1 is equal to 10. Now let's solve f of 4. So 4 goes into our little box, and we rewrite those coefficients. Draw our division line, and remember that vertical line where the constant is. And again, bring down that first coefficient. Then you multiply it by the divisor to get 4. Add vertically, we get 1. Multiply by the divisor 4 to get 4. Add vertically, 4. Multiply to get 16. Add to get 18. 18 times 4 is 72. Add it to the 8, and you get 80, which tells us f of 4 is equal to 80. Now, what else is synthetic division good for? Well, since synthetic division is telling us the possible factors, synthetic division can help us determine whether a number is a 0 to a polynomial or not. And if it's a 0, that means that it is a factor of that polynomial. So here we're given a function and asked to determine if -3 and 2 are zeros. So we'll start with the -3, and it goes in our synthetic division box. And then we want to check our exponents, make sure that we have a term to represent everyone. We do. So we write our coefficients, 3, 5, -6, and 18. We draw our bar for the division, and we draw that vertical line where our constant is. And remember, step 1, bring down that first coefficient. Then we multiply it by the divisor, gives us -9. Add it to the 5, we get -4. Multiply it with the divisor to get a 12. Add vertically to get a 6. Multiplied by the divisor to get -18. Add vertically, and we get a 0. Because we got a 0, it means that this -3, which is the same as x plus 3, is in fact a 0. So yes, x equals -3 is a 0. Now let's check 2. So we put 2 in our synthetic division box, rewrite our coefficients, write that division line with the vertical bar at the constant. Step 1 is to bring down the first coefficient, then we multiply it by the divisor, add vertically, multiply by the divisor, add vertically, multiply by the divisor, add vertically. It does not equal 0, so no, x equals 2 is not a 0. Okay, so one last way that synthetic division can be helpful for us with polynomial functions, and that is synthetic division can help us to factor a polynomial function. And to do this, we're going to look for linear factors. So I like to start with the easiest, which would be x plus 1. And I'm hoping that x plus 1 is a factor. And remember, we need this in the form x minus some number. So that would be x minus -1. So I'm going to try synthetic division with -1. And this will tell me if x plus 1 is a factor or not. So I'll rewrite my coefficients, draw my division line and my vertical bar at the constant. I'll bring down my first coefficient, multiply it by the divisor, add vertically, multiply, add, multiply. My pen doesn't want to write a 0. Add. Okay, we got a 0. A 0 is great. This means that x plus 1 is a factor. So we can start to factor it. We know that x plus 1 is a factor. Now, do you recall what this tells us? Yes, this tells us that we have x squared minus 7x plus 10. That's another factor, right? So I've factored out a binomial, and now I have a trinomial, or this polynomial, left. Now I need to factor this polynomial, and I've fully factored the given polynomial. So we know that we're going to have x's, and we're looking for two numbers that multiply to 10 but add to -7. So how about 5 and 2? And they're both negative. Now we need to solve for the zeros. So f of x equals 0. Well, remember that says that x plus 1 equals 0, or x equals -1. The second factor, x minus 5, could equal 0, or x equals +5. And our last factor, x minus 2, equals 0, or x equals a +2. I hope by the end of this lesson you've mastered synthetic division, or you're at least a little bit more comfortable with it. It's definitely easier than long division with polynomials. Any questions, let me know. Leave it in the comments or send it to me via email, and I'll help get you situated.